Hello, my name is Dorota Jarecka. I work from a McGovern Institute for Brain Research at MIT, and I am part of the Reponym team. And today I will be providing introduction to containers. So let's start from short motivations. And during this part, I want to think about scientific workflows, the various components of the workflows, and their evolution. So from the very beginning, especially in experimental research, you combine experimental data, some theory and equations, scientific computations, and at the end you get some result that you publish in journal, or you share otherwise with other scientists. And I would say that this, you still could, you can think about the same components that you have. However, each of these components has changed slightly, yeah? So we built more complex measurements, and we have much larger and heterogeneous data. Because of this, we also often have more complex analysis, and we often use computer programs to write them. And at the end, we often don't calculate this manually, but we use computers. And computers also became much more complicated. They have heterogeneous hardware and different operating systems. Surprisingly, it looks like the only thing that didn't change is actually the way how we usually publish the results. Although I would argue what has changed is that the results are much harder to repeat. And obviously, entire discourse is about this. And we would like you to show how you can actually create a result that is able to reproduce, that other people are able to reproduce. But before we get to the end, before we can get to the reproducible publication, we have to think about different components. And during this course, and we also doing different courses, we teach about useful tools to gain control over different components. So first of all is data. And today you will hear more about Data Lab. That is data management system that allows you to track history of your data. The other thing is Git that you probably already heard about at least a bit. It's the version control system that allows to track history of your scripts and other files. And I will be talking about containers. And containers basically helps you to control computational environments and allows you to use various hardware in slightly easier manner. So what are the containers? What do they provide? So basically, they provide standard method of creating and sharing computational environments. They allow for easy isolation of your computational environments, and they're much easier to share between different systems like Linux, Mac OS, or Windows. And they also provide some more immutable environments. So basically, even if you change something in the container, you can always return to the initial version of the container. So why do we need containers? So I like to think about usually about long-term perspective and short-term perspective. And I will start from long-term perspective. And basically, this is one of the biggest topic in science and discourse is the science reproducibility. So each project in lab depends on complex software and environments, yeah? So you are using different operating system, different software like Python, MATLAB, various libraries. And basically, without containers, as you know, it's very hard to reproduce. However, having containers, allows you to encapsulate the environment, and later you and others can recreate the environment. However, you also can think about short-term perspective, and I would give you multiple reasons that might convince you to use containers thinking about like short-term perspective. And the first one is collaboration with your colleagues. So as you might already notice that sharing your code or using a repository might not be enough. That you often like your colleagues might still have issue with like running the scripts, but having containers, again, you can encapsulate and share your environment with others, and your collaborate should be able to reproduce the same environment on their own laptops. The other important issue is that you often start on your laptop, but you have to move to other computers because usually like the personal laptop might not be enough at some point because the data is large. And having containers, again, being able to encapsulate the environment allows you to easily recreate the environment on different machines. One of my favorite thing is the motivation is that it gives you also freedom to experiment. Basically, you can try to install whatever you want, but you can always come back to your pristine working environment. You can always just remove the container from your laptop and everything is fine. And the last one is like just using existing environments. So as you might know, installing all dependencies might be pretty hard. And I would argue that that might be exactly also the reason why you might want to use containers, because there are many ready-to-use existing environments. So you might be able to use someone else's environment without any need to install. So short tools comparison. So when we think about containers, you often can also think about virtual machines. So basically, there are like two different technologies. Virtual machines that you might have heard about, VirtualBox or VMware or AWS, and containers. And when talking about containers, we usually think about the Docker and Singularity. The main idea is the same, basically to isolate the computing environment and allow to regenerate and share the computing environments. What is different is that containers are very lightweight and much faster to start up. And during this presentation and most likely in your work, you will be mostly using the containers. So as I said, you have two types of containers, Docker and Singularity. So Docker it's the leading software containers platform, and you will be running Docker today. It's an open source project. It runs on Linux, Mac OS, and Windows Pro without a need of installing virtual machine. If you have Windows Home, you have to install virtual machine first. The problem is that users have root privileges inside the containers that leads to serious security issues. And that is the reason why in most HPC centers, you will not have access to Docker. This is exactly the reason why Singularity was developed. It's basically the container solution for scientific application. A user inside a Singularity containers is the same user as outside the container. So you should not have any issue when you are asking your HPC admin to install Singularity, because there is no concern, there is no root privileges concerns. It's best supported for Linux. So you should have access to Linux when you want to work with Singularity, although some support for other systems also exist. What is good thing, because you often might, in the future, you might have to work both with Docker and Singularity, but what is good that Singularity image can be created from a Docker image. So now we'll be talking a bit, what does it mean to use containers? And I will be talking about the idea, what does it mean to use containers? And in the right corner, I will have an example of Docker commands. So I will start from the simplest one. Is basically Docker run. That means that you are running the containers. I just use the RM flags because that actually make sure that the container is removed from your system once you stop running this. So this is always good to use. And the last part is the name of the image. And we'll be talking more about image later. So let's say you are running this command on your laptop. So basically, when you run this command, the new container is created within your operating system. And what is actually good that you can create like multiple containers on your system. So you are using the same hardware, but the user space and libraries are completely independent. So you can work on like completely multiple, like different independent things within these different environments, within these different containers. But now let's concentrate on like specific containers and think like and discuss what you can expect from the behavior within this container. So let's say like here all of these examples are based on like a FSL image. So if you run this FSL image, within this containers, you have access to all of the FSL software. So one of the simplest command is bat. So you can always run, if you have the containers, you can run every single command you would run on your laptop, having FSL as normally. So you can run bat help, and you should be able to get full help. However, you might notice that right now there is no connection between. So as I said, like they should be completely independent on your user space. So in this very simple command, we didn't create any connection between user space, your local user space and your container. So there is no access to your local directories. Therefore, like using bat is not very useful because you don't have access to your images. So next thing you should think when running the containers are the connection you have to build between your containers and your local machine. And the connection we often call bindings. So the most common bindings you would like to create is the bindings with of the local directories. So if you create the bindings with the local directories, and in order to do this, you have to basically add the argument -v and provide the path to your local directory and also the path within the container for this directory. And that's when you allow your container to be able to see your local files and directories. You can have different options for this. So especially, running analysis and running them on like raw data, you might actually ask container to create the bindings only in the read-only mode. That might be very useful, but you can also like, especially if you wanna also like write the output somewhere, you can also like create bindings that have the right access that is actually like as a default. And here, like today, we will not have too much time to work with Docker, but there are several commands that you might be interested in checking. And like just very quickly, because I was using the word image multiple times, and just want to say like briefly what is an image. So this is basically a immutable file that contains the source code, libraries, and dependencies and files, etc. And can be treated as kind of like snapshot that represent environment and other software at a very specific time. That's what we call like the image. Docker image from technical point of view contains multiple layers that can be reused by various images. And in order to run a container, you always have to have image on your laptop. And several containers can run the same image. So when you create the containers from image, as I said, like from one image, you can create multiple containers. And later you can completely independently changing the containers that you already created from the image. So as you see, like, you know, when you start running the containers, all the containers are the same, but later you can change them. So how do you get the image? So first of all, there are many easy, like ready to use images from Docker Hub. You can receive from your collaborators, but you can also build your own from Dockerfile. And you will be discussing more how to do it